Now today I'll discuss about the variance of a data. Sometimes we find the mean of the two data is same, but they differ very significantly because of its another characteristics that the how far the items are away from the mean. More closely to the mean, they are more accurate, more consistent of the data, and when they are away from the mean, the observations are away from mean, they are more scattered, then we say the more variance. Variance, the word has come from vary. Vary means change, how the item are changed with respect to the mean. Now friend, x1, x2, x3, xn are the suppose the observation. Then the standard deviation given by xi means all of the minus x bar whole square summation divided by n. We can simplify further. We find we sometimes use this formula because the mean sometimes comes in decimals which are difficult to calculate. Now, what is variance? Variance is the square of the standard deviation, and you find always this is always a positive quantity. This is here it is. Now I go with the one when I find this, if I take ui is equal to xi minus a, this is called shifting of the origin, then I know x bar, u bar is x bar minus a, and the difference is this. Then I can find standard deviation with respect to x and with respect to u are the same because this is equal to this, and therefore this with respect to is the same. There is no change in the standard deviation here. There is no change. There is no change of it is independent of change of shifting of the origin. Variance is one which is not affected by shifting of the origin. Let's talk about the how it varies when there is a change of scale. Now suppose x1, x2, they have standard deviation is equal to this sigma. Then what this is? Okay, we said the shifting origin does not undergo a change. Now we go to next part that we have got the change of this scale. This scale is dividing by h. Xi will divide by h. What ui will be? What is standard deviation of this variable u? Let's multiply. Let's use this divide. Put the value square here, and we find this one is equal to h square. Then what is this new variable? Standard deviation is equal to the variance is square of this, and therefore standard deviation of new variable will be another variable divide by h. If you divide by the h, the same will be divided here in this case. Now I got example that suppose you got x1, x2, x3. They are the these are the one series. Standard deviation is equal to what sigma. Then what is this new variable x1 minus 5 upon 3? This upon 3. What will be SD of the new variable? Then what? There is no change because of minus 5. However, there is change of 3. When xi divided by the 3, then new variable will have standard deviation of divided by 9. Square of this. Standard deviation variance will be divided by this. Standard deviation will be divided by 3. Now suppose I got a standard deviation of 5 series with 5. What is standard deviation of the u? Which is like this. So no change because of this change of this shifting of the origin, but multiplied by 3. This is equal to standard deviation multiplied by 3. In case of, now let's say another example that suppose ux, this is standard deviation of this is equal to 2. And then what is the standard deviation of the u? 3x plus 5 divided by 4. Now this I can put it like, there is no change because of this origin. There is no change. However, there is a change here. Standard deviation will get multiplied of this. The new one, u will be changed to 3 by 4 into 2. That's how. Now in this case, we found that standard deviation of because of the change of the origin, there is no change in the variance. However, when there is a change, when the change in the scale, it gets multiplied by same way. Now I come to the next, this combined standard deviation of two series. We have got combined series. Now suppose n1 and n1 is the number of one series, x1 bar, and this is this one to here. There's two conditions are given. First of all, I'll find the combined mean, which we have learned earlier. We'll combine mean. Then I'll use this formula. N1 into sigma 1 square, N2 sigma 2 square, N1 into D1 square. D1, what is D1? This minus this. Combined mean minus mean of the first series, combined mean minus this one. And this is D2 square. Let's suppose N1, these are given to me. N2, 62 is the mean of the second series. Descent of second series, we find the combined mean, compound this 468 plus 100 into 65 divided by 500, we come to this. What is D1? This minus 68, this is 1, this minus this, B1. Applying this formula here, I got this D1 I found, D2. D1 is what? X bar minus X1 bar. I applied this one to go. N1 into sigma 1 square, N2 into sigma 2 square, this is D1 square. I calculated, I got the answer, this is the answer is here. So we can apply this formula which I mentioned earlier. Now another coefficient which we talked is called coefficient of variance. This is standard deviation divided by mean in 200. Whenever we want to compare the consistency of the two data, then usually use this coefficient of calculation. It is without any unit, and this is always in percentage. So we have got this question. These are standard deviation. Now let's do the question that are asked in the examination of NDA. The first question I would like to discuss: what is standard deviation of 7, 9, 11, 13, 15? Okay, this was asked in NDA. We'll put it here. I completely see that this is the mean because they are X bar. This is done. Scaling this is the formula for standard deviation. Sum of the square divided by n. This is here. N is equal to 5. This is total under root 8, approximately 2.8. Therefore, answer is 2.8. Simply, you take 1 minute to do this question if you know the basics. Now, here the second question comes: if X bar is 2 and standard deviation is 2 by 3, then what is coefficient of variance? What is the coefficient of variance? What is the coefficient of variance? What is the coefficient of variance is equal to? Coefficient of variance is equal to, I said, standard deviation upon mean in 200. The standard deviation is 4 by 3. Mean is equal to 2, and into what? Into 100. 2 here is a 200 by 3. The answer is C, 200 by 3. Does not take much time to do the question. Third question says, if the variance of the data 2, 4, 5, 6 and 17 is mu1, V1 say, what with the variance of the data 4? Let's multiply by 2. Each one multiplied by 2. New variable which we have or multiplied by original one. Therefore, variance will be what? Variance. Then this will be square of that. Multiply by 2 here. So it is 2 square, that is equal to 4 into variance of this. Variance of the new variable is equal to h square of the another one, x square. This is what we have got. This is, if this is multiplied by this, this is, if it is the earlier one is x, now here is multiplied, the variance will be multiplied by square of this, square of this, this is square of this is square of this, h square into this. The new variable, this variance of this is equal to h square. H is equal to here 2 divided by earliest the variance of the another. Variance equal to v1. Therefore, the answer is equal to this. Standard deviation of 15 items is equal to 6. Each item is decreased by 1. There is no shifting of the original meat. Therefore, this will be unaffected. Unaffected. The answer is this. Okay, we have done. Variance is always independent of change of origin, but not of the scale. Right. It depends upon change of scale. Variance of the earlier is equal to s square into this one. There is a change in this case. Therefore, answer is 1. Its variance is affected, is independent. It's independent of change of shifting of origin, but do have effect on the change of scale. Here is the one formula to go. So we got a question like this that can be easily answered. The concept are clear. All the force for NDA examination. Thank you for listening me.